This video in the series about business process re-engineering will look at business process methodologies and mapping, which is the fourth in the series. We're going to look at the Rumler-Brack process improvement and mapping example. So here are some of the distinguished clients of Rumler-Brack, such as Lloyds TSB, Bank of Scotland, Pfizer, as was GlaxoSmithKline, quite a few major companies. And their methodology looks at different levels. So 3 performance levels and some managerial levels, which are put together in a grid called the 9 boxes model. So the 3 levels of performance are the organisation, the process, and the performer of the process, or people levels. So to effect change in an organisation, it's necessary to understand the potential impact of all 3 levels. For example, a process change could mean significant changes to job responsibilities and the skills required to execute those responsibilities. So down in the bottom left, under goals, it would change the job specifications, performance metrics, and individual development plans. Failure to adequately account for these interrelationships is a major cause of process implementations that failed. Similarly, we have 3 performance dimensions, and these are goals, design, and management. Having clear goals at each level ensures alignment to target results, and having robust design at each level maximizes operational efficiency. And finally, having good management systems at each level ensures that the organisation can survive and adapt to changes in the business environment. A failure in any one of these dimensions will also be likely to lead to business performance problems. So let's just have a look. Here's a Rumler-Brack methodology map, and it's kind of a cycle, at least to start with. So in phase 0, which we find here, this is about assessing and drawing up a performance plan, where we look at gaps in where we want to be. So we do a gap analysis, and we set goals for what the process changes are going to achieve. In phase 1, below that, we define the project, refine the project goals and boundaries, and we set up the project that's going to do the reorganisation. In phase 2, we develop the is now and should be situations. So this is where we start to look at how we're going to improve each part of the process. We know how it is now. We create the performance metrics that are going to allow us to see how well we've changed the process when it's successful, or if it has been successful later on. Phase 3, deploy, and then manage the change. This is where we implement the improved processes, the should or to be processes, and monitor how effective they've been. And then phase 4 is all about sustaining those achievements and capitalizing on them as a kind of performance management. And finally, in the adapt stage, where we've gone around that improvement cycle, we go more into continuous improvement, adapting the firm, using it as a system with all the new to be processes active. A Rumler-Brack process profile basically starts with a trigger. That's the input that initiates the process, and then moves through where all the materials, information, money and people, all the resources used to produce an output are taken in. And so in that section, scan, these are the process steps, the big value added chunks of work that are going to result in the changed setup. The output is the key result or product of the process in question that we want to achieve. And we would have one of these process profiles for every single major activity, as you'll see in a minute. And it's the customer that then is the receiver of the process output. We map process relationships on a process relationship map. And on the left hand side here you can see in the vertical column, these are the actors in the process or in a series of processes, the actors in the whole model. And the blocks are the activities that are happening within the system, and then you have information flows which are flowing between the different activities. And if you look, there are some horizontal lines, and you could refer to these as swim lanes, and we're going to come on to swim lanes and how you would do one of these maps a little bit later. Building the model, it usually requires the creation of a process inventory and a process profile for each process in order to ensure completeness and to keep track of what's going on. The Rumler-Brack tool metrics chain, against each part in the process, so between activities, we have a station. So you can see there are some, and at those stations you develop some sub-process metrics. So at M2 there are some metrics which are linked to results, M1. So we're looking for pay accuracy, that kind of thing. That's the quality, that will measure the quality of how good our process is. We also, in the time level, we have late pay as the thing that we might be wanting to improve. Under cost, we want the cost of, we want to reduce cost and measure the cost. And under capacity, we have various things like productivity at various levels that achieve that output. And obviously we want to have better productivity. So we have metrics that will tell us at what point in the process things are being affected. So for example, under M2, invoice aging, how long is it taking us to collect money, and when perhaps invoices aren't being paid on time, that kind of thing. So there's lots of metrics that we can set up and tabulate in this kind of metrics chain to show how we're going to improve the process. So thinking about visualizing processes, there's something called business process mapping. And its simplistic way, drawing a process map, you can do that, and quite often people do that by writing down each individual activity and posting it on the wall as a post-it note. You can also do the same thing drawing on Perspex or on a Nobo board, or if you want to use an electronic tool, you can use something like Microsoft Visio or a business process management notation tool. What we're looking for is to define what the process does now, decide how it could be improved. Perhaps that might be employing fewer process stages, or it might be to complete the task with less people. We saw examples of that in the Orbit project that Cisco ran. And there are so many examples available. And we're going to look at some of those examples in the case study analysis that we'll be doing around this subject. So we draw out what happens now and then brainstorm a better set of processes. This leads us to Rumler-Brack maps. So here's a kind of more schematic version of in this case it's a software development project, and these are actors: software developer, database architect, systems architect, project manager, salesman. These are the titles of the swim lanes which go horizontally in this case. And you have the activities here, like constructing a work breakdown structure for the project. Is it a suitable project? Allocate resources, determine system design. it's just a good way of visualizing who's involved in what stage of a process and in what area. So the horizontal lines are borders for the swim lanes. Benefits of process maps. You can define the as-is business process and clarifying changes needed to transform the process to optimum should-be status, what we're going to the to-be stage. Determining whether as-is measures of performance, such as KPIs, are adequate, or whether new ones are needed for revised processes. Identifying actors' responsibilities, whether they need training or an appraisal. We can see the impact of an actor on upstream or downstream actors. Highlight workflow inefficiencies, delays, queues in particular, bottlenecks, etc., handoffs to other people. And then identify streamlining opportunities and the need for audit control. So can we improve those processes and take out some of those steps? When you're drawing a process map, here are some of the symbols you'd use. So a rectangle for activity. And you've got off-page and on-page connectors where you've got a multiple page process map. You connect between each page through those connectors. When a process finishes, that's the end of the process. And information flows are just drawn, or they're identified against an arrow that's between a couple of activities. Process map drawing steps. Define a purpose for process mapping and explain it to all those who are going to be part of the project. Identify process scope so it's not too broad and complicated. Scope creep is one thing you want to guard against on any project. Determine those roles that are part of the process via swim lanes, so drawing on the activities, etc. Horizontal to emphasize the process. Vertical if you want to emphasize the functional units performing the process. And then determine the trigger for the process, e.g. fill out an application. That's that's a little sub-process that is being re-engineered. Then events move left to right. Things like receive something, you can just draw as a line. It's not really an activity. And then the last swim lane is reserved for the IT element. That's the actual IT hardware that's doing the process that still might be part of that. So as you can see, in this case it's the MTS 900 computer that handles sales orders, billing, cash receipts, etc. electronically. But again, we have here's a order fulfillment chain with a customer, a sales clerk, a stock person, and the computer involved. And on the left hand side here you can see some of the steps that have been involved in that process, that project. Here's the same kind of thing in an earlier version of Microsoft Visio. So you can see pretty much a bit like a data flow diagram in relational database development. It gives you an idea of flows of information, etc. This is another element with mapping in Visio 2, and here's a more recent version, Microsoft Visio 3. Here the swim lanes are vertical where the process is contained in one area. So we didn't need horizontal swim lanes in this case. And here's you can decompose a sub-process. So here we've got sub-process 1.4 with you notice that all the activities are identified with numbers in this case. So again, you have the swim lanes, but when you decompose that process 1.4, it takes you to another set of swim lanes. So this is a way of having more swim lanes if you need them. Notice going back here, you had customer marketing, sales, product management, engineering, but here you have product manager, director of product management, engineering, etc. Here's another map. This is responding to faults, a service process, and you can see that you have a service call center that handles a lot of that. There's a customer engineer who actually does some of the work in sorting the service problem later on, and then you have various databases that are logging decisions made, parts issued, that kind of thing. Again, that's at the bottom. Other things you can add to process maps: you can put the flow time or distance of part travels. You can denote delays, queues or setup time, inspection times, part rejection points and parts storage areas. Where you've got delays and handoffs, that can indicate an inefficient process where it's not going as fast as it could. So all these things are things that you can look at and think that's an opportunity to redesign the process and do some re-engineering. And just going back to that, most firms buy goods and services, process them and sell them. So you can make that clearer by adding extra task instruction notes and task notes. So just make sure I didn't go over 2. No, okay. So extensions to process maps. So if you can't fit all the data that you really want to fit onto the thing, you can use subtask info, effectively extension notes. So these are task tables, in fact, and you can see a task table here. Step 1, retrieve picking ticket from sales clerk, and it just gives you more detail about a particular activity and who's involved. So this is another way of extending process maps and making them even more feature rich. Hints for constructing the maps: make sure every area of the map contains about the same level of effort. Start with a high level map and explode activities to show more detail, as we saw earlier. Keep a glossary of terms to prevent losing track of map notes. Use humps where information flow lines cross. Allow swim lanes to retain the same role throughout the map, even across several pages of the same map. But again, you can use a high level map and explode activities to if you want to change the swim lanes. Terminate the process in the swim lane where the process ends. Sounds pretty obvious really, but that's where you would do it. Use horizontal swim lanes for maps drawn. If I ask you to do a swim lane diagram, then I would ask for a horizontally aligned swim lane drawing. So we look at as is process map. It documents the current process. Interview all the process owners and actors to learn how the process works from end to end, which may yield comments like, do we still do that? Why are we doing it that way? You mean this report doesn't get reviewed at all? Each activity in the process should be examined to see if any of the following issues are present: handoffs, which may result in miscommunication, mistakes and delay, bottlenecks, insufficient resources available to one process task, and rework, people fixing errors, sources of which should then be found and not ignored. And that enables us to think about how we're going to reorganize things. Other things to look for: role ambiguity. Process maps should define who's responsible and not have some kind of doubt about who does what task. It should look for data duplication to see if there's data sharing possibilities and whether you can have centrally located data that would be referenced by everyone. Cycle time and flow time, look at those. How long does it take to finish a task, and between steps tasks, and can we reduce that? Non-value added steps. There may be some things that people are doing that just don't add any value, so why do them? Then we have repetitive steps that wind backward, which indicate they're redundant. Authority ambiguity. Each process step should have an owner, so where there's kind of doubt about it, there may be a re-engineering possibility. It may be that some decisions really aren't needed. The process could have gone on without a decision at that point. So eliminating decisions where possible speeds up and reduces complexity, speeds up the system. Making a decision too early or too late can lead to confusion or rework. So setting it up properly is something that needs to be done. And then you eliminate all these problems to create both the to be or the to be map, or what you might call a should be map. This should be created thinking about who's the customer and what is the customer willing to pay for, and what does the customer receive. We look at the is now map, and then look, how well does that meet the customer's needs? What level of performance does the customer expect? How well are we satisfying that need? What interaction with the customer starts this process? So you would look at what are the most important value-added steps in the process, and what is the scope for this change? What tasks are out of scope? So process mapping. I just thought you would benefit from seeing some process mapping done in Lean Six Sigma process mapping, and there is a video by 100% Effective Training that's really quite good. So if you go to this YouTube link and play that video, this one here, and just watch that through, it's fairly well covered, although the recording isn't the best, but it still gives you a lot of good guidance, and you'll be able to find that in the Enterprise Solutions portal, or from the slides, just by running them in slideshow mode and then clicking on here. As you can see, if I click on here,
welcome to 100% Effective Training's introduction to process mapping for Lean Six Sigma. Over the last 15 years, we've conducted countless process.
So you get the thing running. So we'll come out of that.
Around the world.
Right, here we go. We're back in. So here's the BPR TV. Back to the BPR TV, and that is this module complete. Thank you for your attention.